Dear friends, hope you had a great summer vacation. In this episode, we have Professor Bart van Arum, who has received the lead award of IEEE ITS as our special guest from TU Delft University. He will talk about intelligent vehicles and their impact on our lives. Also, he will talk about his activities and his lab in TU Delft. As usual, we are starting with a short news mini section. Then Professor Haluk Eren from Farad University, Turkey, will continue with a review of a book about transportation networks. This is the news mini section for episode 48, September 2018, and this is Dr. Mayam Kaveshkar. One of the main names of driverless car industry, Waymo, is heading to China. Waymo is setting up an office in Shanghai's Free Trade Zone, according to a filing with China's National Enterprise Credit Information Publicity System, a business registration website. This will be considered a base for its parent company Alphabet in China, especially since Google is considering reopening its search engine behind a Great Wall. They will test and design autonomous vehicle parts and products. Yale Zhang, managing director of Shanghai consultancy Automotive Foresight, said many Chinese car makers are small and don't have the resources to develop autonomous driving systems on their own, while larger players will be forced to keep pace with Waymo. For Waymo, the attraction is clear. China is the world's largest auto market. Waymo is facing a serious opposition from Baidu. Baidu is the Chinese search engine, and as the central government has mentioned, it is also the national champion in self-driving initiative. There is one more problem. In China, high-definition mapping is strictly controlled, and driverless cars are highly depending on it. The only companies licensed to provide mapping are Chinese, including Baidu, Alibaba, and Tencent, all three backing separate driverless car projects. So far, BMW and Daimler are the only companies provided permission to test their autonomous cars on Chinese roads. Waymo has to obtain the permission and has to face more difficulties on roads like more number of pedestrians and electric bicycles. In the other continent, in Canada, the city of Vancouver is given a special budget to be prepared for future driverless cars. Dale Bracewell, manager of transportation planning, said technological advances are changing how Vancouver's future is seen when it comes to transit and transportation. He did not mention when the city will be ready for driverless cars. However, as a part of the plan, the issue that the city would have to focus on before introducing a fleet of driverless cars is wireless connectivity, because of the problems that could result with the vehicle if there is an insufficient wireless network. In the Autonomous Driving 2018 conference in Novi, Michigan, Jack Wist, senior principal engineer and chief system architect of autonomous driving solutions at Intel, introduces RSS, Responsibility Sensitive Safety. According to Jack, synthetic testing is not enough to safeguard the safety of the passengers of autonomous car. By taking advantage of a set of sensors and a mathematical approach, Intel's RSS monitors the vehicle. These are the algorithms that tell the vehicle how close to follow the front vehicle or how close is safe to the car in the next lane. When there is violation, the car will correct it. In essence, it will reduce the speed to establish the safe distance. Scenarios are countless, and RSS from Intel is working on it. Did you know that there is shortage of 50,000 truck drivers in US only? Well, this makes semi-trucks an easy goal for driverless car developers, and a new startup is getting the business. It is called Kodiak Robotics, co-founded by Don Burnett. Previously, he was the co-founder of Otto, the section of Uber making autonomous trucks. Left it in April, and a few weeks ago, Uber shot its autonomous truck program. Kodiak will be joining other startups like Starsky Robotics and Sweden's Einride, which is so convinced it won't need a human on board. Kodiak believes that semi-truck development could move faster. Freight won't complain as much about a slightly jerky ride, and if engineers focus on highway and interstate driving, that constrains the problem by removing cyclists, pedestrians, and traffic lights. You get on road, stick in the right lane, and don't hit the thing in front of you, says Burnett. This is certainly a good start, but definitely not replacing the truck drivers yet. Reuters reports from San Francisco that Lyft has already surpassed 5,000 rides with its driverless cars, a serious competitor for Uber. Lyft is partnered with a high-tech auto parts supplier, Aptiv, early this year. The company is developing its own self-driving system, but they are not quite sure when it will be ready for streets. Well, that is for news in this episode. Now let's listen to Haluk, who had reviewed a book about vulnerability analysis for transportation networks. Go ahead, Haluk.
This is the book review section for ITSPodcast, reviewed by Dr. Haluk Eren, Fırat University, Elazığ, Turkey. The book title is Vulnerability Analysis for Transportation Networks and consists of 274 pages. Produced by Elsevier in 2018. Written by Michael Taylor. Vulnerability analysis for transportation networks refers to a comprehensive framework for understanding all modes transportation networks, while it is partly failed or substantially degraded due to congestion incidents, natural disasters, road crashes, extreme weather conditions, or road repair. Collapsing the bridge in Italy is a good up-to-date example, integrating many resultant components into the road vulnerability. The present book combines the concepts, theories, and methods with existing approach to network vulnerability, exemplifying case studies around the world. It mentions about applications for different approaches, including the critical locations and infrastructure components in the networks, the estimation of the potential impacts of network degradation or failure, and the planning and design for remedial actions in the case of failures. There are 8 chapters in the book. Chapter 1 gives a detailed introduction. Chapter 2 handles critical infrastructure systems on transportation. It discusses the potential reliance of the transportation and the other infrastructure systems, like the energy supply system, to understand the interaction between them. Here the vulnerability and resilience are elaborated as well. And the chapter introduces an outline for a vulnerability analysis framework. Chapter 3 states the essential approach to vulnerability analysis, which are risk-based inventory analysis, topology, serviceability, and accessibility-based analysis. It consists of conceptual and theoretical sides of this approach, including risk-based inventory studies and an introduction to topological methods. Chapter 4 mentions about the serviceability methods involving in road networks and their functionality. Chapter 5 handles the accessibility-based methods oriented to studies representing social and economic impacts of network deficiency. Chapter 6 addresses vulnerability analysis of public rail transport systems, such as subway, underground, or metro systems, for which topological methods are developed. These types of systems encapsulate new serviceability analysis of transit systems in static and dynamic modes. Chapter 7 refers to a vehicle for the future comprehensive study of vulnerability. It combines the 4 approaches in an integrated framework, having the common features of network structure. Also, it supplies with the specified data input for them. The chapter gives good suggestions for the development and application of vulnerability analysis tools, matching to the best application areas. Chapter 8 elaborates the necessities for new associated research areas to fill in gaps in present accumulation. It also generates a research agenda inappropriate to underlying considerations. This book could be a useful material for researchers in transportation networks and for professionals working on design, management, and planning of transportation networks and services.
Thank you very much, Haluk. Now let's sit back and listen to our interview with our special guest, Professor Bart van Arem.
Hello listeners, in this episode, in September 2018, we are with Dr. Bart van Arem from TU Delft in Netherlands. Over there, he became full professor of transport modeling sometimes in 2009. He is the head of the Department of Transport and Planning and the director of the TU Delft Transport Institute. He received his PhD in applied mathematics in 1990 at University of Twente, and he worked as part-time full professor there from 2003 to 2012. It is also worth mentioning that he was a part of TNO from 1991 to 2009. His research focuses on analyzing and modeling of implication of intelligent vehicles. These implications can vary from human factor all the way to traffic flow on roads and networks. They have an instrument vehicle and a driving simulator, and the empirics derived from there will be used in very strong modeling and simulation component. Welcome to our podcast, Dr. Arem. So, Dr. Arem, would you like to add anything to my introduction?
Well, thank you for this very nice introduction. I think it's very complete, and I'm happy to contribute to this interview.
So, let me ask you the first question from your research interest. Could you briefly let us know what do you think? Will intelligent vehicles solve the problem of congestion, and if yes, how will it happen?
Yes. So, wouldn't we all like to have the ultimate solution to congestion? But I'm afraid that we will probably still have congestion in the future. So we allow freedom of travel by people, and demand for traveling is growing. So there will always be a balance between the demand and supply of infrastructure. But I do think that intelligent vehicles will add to the efficiency of road traffic. We cannot completely eradicate congestion, but for instance, we could drive at shorter headways. We could reduce the shock waves occurring in traffic. We could make traffic safer, reduce the number of accidents. So in that sense, I think intelligent vehicles are going to improve traffic flow efficiency. And for instance, when we would drive automatically, then of course we can make much more use of our time while we're in the car. And for that, I think also it's not only about developing smart cars with smart sensors, but also communication between cars and infrastructure will be vital.
Thank you. To follow our previous question, let's bring up your paper published on 2017 in IEEE ITS magazine, which talks about empiric comparison of ACC on and ACC off in vehicles. It is titled as Driving Characteristics and Adaptive Cruise Control, a Naturalistic Driving Study. Please tell us about your findings and the outcome of this project.
Oh, that's a very interesting question. Glad you asked it. So previous research we've been doing was based a lot on modeling and making assumptions on how automated vehicles or vehicles with adaptive cruise control would be driving on roads. And this is one of the first studies in which we used a number of vehicles and evaluated and studied the behavior of how people that use those vehicles in real life. So we had the opportunity to use 8 regular ACC vehicles. They were part of the lease fleet of a consultancy firm in the Netherlands, Royal Haskoning DAB. They also funded this research. And we let people drive with and without ACC each for several weeks, and we measured the driving behavior of these people and also their appreciation of these systems. The findings were quite significant and relevant. So if we look at ACC driving at the moment, we found that ACC cars, they use longer headways compared with human driving. So whereas a human driver would use a headway of about 1 second or maybe 1.2 seconds, the ACC cars, they use a headway of 1.5 seconds. So this kind of means that if in the future we want to move towards smaller headways to improve traffic flow efficiency, we still have a job to do in the development of more efficient ACC systems. Another finding that came from that study was that we looked on how often people change lanes when they have adaptive cruise control compared to regular driving. And also results there were quite significant. People if they use their adaptive cruise control, they stick to their lane more than when in regular driving. And this was done in the context of right-hand driving being mandatory as we have in the European mainland. This is also quite important because, for instance, if we want to learn how it would be if we have 20% of the vehicles equipped with adaptive cruise control and study that in simulation, we would need to adopt our driving models accordingly.
Thank you. How the people in Netherlands have accepted the ACC and platooning? Has it become popular? Have you done any research about this?
As in many other countries, I think the development and the deployment and use of adaptive cruise control is developing gradually. So I would say that not more than 10% of the cars that are currently sold do have ACC, and people are gradually gaining experience. Remarkably, most of these users are high-income males. So also in terms of the type of users, type of population, I think there's still room for development there. When it comes to platooning, this is a more advanced part. Platooning is formally not allowed on public roads. We did have some experiments though on platooning, and I can say already that the first experiments that we did on platooning was together with UC Berkeley in the Netherlands already 20 years ago. The experience stems back from then. More recently, we have been doing platooning experiments with truck platooning. This is important and relevant for the Netherlands because our position in freight transport in connection to the port of Rotterdam and our main port Schiphol is very significant. So efficient transport is important for us, and we see truck platooning as a possible way of doing that also in the future. So in terms of truck platooning, there is a large potential, and we have several projects dealing with the experiments here.
After that question, what are the society implications of autonomous driving? You have done a research on this. Please share your point of view.
Well, when I kind of look at the impression on the level of funding that is going into automated driving, I have a feeling that about 95% of this research goes into the technology and still little insight is being gained on the societal impacts. But these could be very substantial and deep. So for instance, we could look at changes in travel behavior. So if I would be having a automated car and I could use my time differently, then I might consider buying that little beautiful house in the countryside, and I would have maybe a 2-hour commute, but that would not be a problem because I could use my time differently. That could lead to very different spatial patterns in travel and in land use, and that could have very wide societal, especially spatial implications. I would say also, in addition, with electric and shared mobility, there are also new options for redesigning cities. So a lot of space in cities is consumed by parked cars, by roads, and if you can use automated electric and shared vehicles, you could reduce the need for parking places. You could use the space that you have for recreational purposes, for commercial purposes. You could increase the quality of cities a lot. So what I see now is that urban planners are very, very much interested in these new ways of mobility, including also, and I must say that, combination with public transport, combination with cycling, and especially when you have electric bicycles, this is becoming a very relevant transport mode, and walking. So it's a very interesting mix that automated driving is going to have, I would say, in combination with other transport innovations.
What is this Transport Week you have initiated in one of your courses? For the information of our listeners, let me include that Bart van Arem, in addition to MSc course of Intelligent Vehicles for Safe and Efficient Traffic Design and Assessment, has a course in BSc in which he teaches Introduction to Civil Engineering, and mainly he introduces students to the basics of transport planning. And this Transport Week is a part of this course. So please go ahead.
Thank you for this very interesting question. Every year, TU Delft is welcoming about 400 to 500 new bachelor students in civil engineering. And it's a major enterprise to also teach the broad spectrum of civil engineering to those students. And in the course of Introduction to Civil Engineering, there is indeed this 1 week which is focused on transport. In this week, we teach students about the fundamentals of transport, like supply and demand of transport, traffic flow theory basics, these type of things. So what is a transport network and how do you assign demand to a transport network? Of course, this is within 1 week, so it's still basic. And the main thing that we challenge the student on next is a case study. So the case study represents the region of Delft, and we give the students the situation where one of the bridges in our network is taken out for 2 or 3 months for renovation. And it's unavailable during that time, and students need to develop solutions on how to maintain transport flowing in that network. And dealing with those solutions, they can use new technology, they can build temporary bridges, they can use cycling, public transport, so whatever they like, but everything comes with a cost, and we evaluate their solutions in a model that we have of the Delft region, and we evaluate their benefits against the money that they spend for their solution. So it's very exciting to have about 400 students working on this type of problems, and very often the solutions that we get are out of the box. And
yes, Bart van Arem, you received the lead award of IEEE ITS in Yokohama in October last year. Every year ITS gives this award to whoever has made significant contributions to demonstrate leadership in promoting ITS technologies, ITS Institutional Lead Award. Please tell us about this award.
I was very happy to receive this award. It's a big honor for me, but also this extends to the team of people I work with at TU Delft. And roughly the people that I work with, the group, comprise about 30 to 40 people. In terms of the topics that we have been studying during the past years, this is about studying how intelligent vehicles interact with humans, how they interact with traffic flows, and what their impact is going to be on society. And indeed, referring to the very first question, to which extent will it solve congestion? Referring to the ITS magazine paper that was about assessing the interaction with humans. So it's a combination of research with people with a control engineering background, a human factors background, a civil engineering background, a mathematics background. So it's a multidisciplinary program in which I'm happy that we've made steps to develop new theories, new methods, and at this moment moving into empirical research more and more.
Thank you. Bart van Arem, tell us about RAD. Is it right? It's called RAD. What is the main goal of this research lab?
The research lab, Automated Driving Delft, RAD in short, is part of a network of locations in the area of Rotterdam, Delft, The Hague. It's about 8 areas where pilots or applications of automated transport are taking place. So it's a coordinated effort, and maybe worth to mention, one of the sites we are working with is a site near Rotterdam. It's called the Rivier Park Shuttle, and it's a level 4 automation system that has been in operations for already 15 years and is developing into new stages. In the RAD facility, we focus especially on the research aspects of automated driving in real life. And RAD is established on an area that is regulation-free. So we have exemption of regulations, but we work with existing regulations as much as possible to get approval for experiments with vehicles from the roadway authority, from the area manager, but also from the vehicle type approval authority and our ethics committee. So it's a site where we have established certain facilities now already regarding zebra crossings. We have traffic lights, we have several vehicles, and we work there with public and private partners. The ultimate goal that we're working on also is to extend the research lab not only to automated driving, but to urban mobility in a more general sense, to study the interaction of automated driving also with pedestrians and cyclists and regular vehicles.
Yes, and there are a fleet of vehicles in RAD. Could you tell us what are the purpose of each and how they differ from each other?
Currently, in the RAD test site, we have 2 Toyota Prius vehicles that are equipped for automated driving, especially on the sensing part, and they are meant for doing research on, for instance, evaluate crossing behavior of pedestrians before such a vehicle, but also these vehicles go out in the field and we can study how people interact with the vehicles with and without automation. One of those private vehicles is used development. So that's the group of Professor Dario Gavila that we're working with intensively. The second type of vehicle is a small electric vehicle. It's a Renault Twizy, and this is a vehicle that we are developing with our rail infrastructure provider. They're interested in making this vehicle available at train stations for people to take the vehicle, and after they reach the destination they can leave the vehicle, and the vehicle will be able to drive back automatically to a next user or to a charging station or to the station. So this vehicle will be able to allow automated driving at low speed, and we are also considering letting that drive on a cycling path. And for people who might not know the Netherlands that well, the cycling path infrastructure in the Netherlands is almost as extensive as our normal road infrastructure. So it's a very extensive network. The third type of vehicle is an automated shuttle, and this is a vehicle that we have been developing in the province of Gelderland to provide connections to the University of Wageningen and the train station. It's one of the many automated shuttles that we see in operation nowadays, meant to provide additional transport in addition to regular public transport. The fourth vehicle that we have is a small roll-up platform. We can use that for different types of applications. So if you put a pizza box on it, then it becomes a pizza delivery. But we can also put a puppet of a pedestrian on it, and then we can use it in experimental settings to mimic the behavior of a crossing pedestrian. In addition to the vehicles, we have smart bicycles that can communicate also and have advanced sensor systems. They're not automated, but they're part of our equipment. Finally, I would say it's good to mention that we use traffic lights provided by our industrial sponsors that the vehicles can communicate with.
Thank you. And what is your plan for future research?
My future research would be geared at a concept that I would call self-driving cities. So what would it be, how would cities look like if we could have large-scale deployment of automated, shared and electric transport? We could even redesign cities there. How would people use them? Which type of technologies do we need for that? How we can change the spatial layout of cities. So something that I'm also doing with the faculty of architecture. How will people interact with those systems? What will be the energy implications of the use of these systems? And so this research on these type of applications is still scarce, but I see that authorities, especially city authorities, are very much interested in engaging in this research with us, and they also would like very much to open up their cities for experimental deployment of these type of systems. And I think that is very important, that we extend all the modeling work that we do also with empirical work that will allow us to verify the assumptions that we do in the modeling using real-world experiences.
Dr. Aram, will you be with us in Maui? As everyone knows, the next conference of IEEE ITS will be held in Hawaii in November.
Oh, that would be very exciting. I organized ITSC in The Hague myself some years ago, and Hawaii sounds pretty exciting. I have no final plans yet, and during that period I have plans to visit China, Japan and Australia, so I might do a real world tour if I would include Hawaii in that schedule. Let's see.
Yes. Bart, would you like to add anything?
There are two things that I would like to add, and that would be more on a personal basis. So one thing is that I would like to compliment all the volunteers in the ITS Society that are currently developing the society to a really higher plan, and one of the significant organizations in the field of ITS at the moment. I've been witnessing and been part of the ITS Society from its early days, and it has grown a lot in significance, in initiatives, and I would like to compliment all the people that are making this possible. The second thing I would like to add is also a call for all the people in the society, in our field, to keep working together. I appreciate very much the worldwide collaboration that we have in the field of ITS, the exchange of research results and the positive feedback that we give to each other, and even friendships that we develop. I think it's important to cherish them, particularly in the current days where our political landscape is changing. I think there is a huge responsibility for the scientific world to maintain proper contact and keep advancing our world to a better world.
Well, thank you very much for sparing some time to talk to us, accepting to be with us. I hope we see you soon, Bart van Arem.
My pleasure, likewise.
Thank you.
Thank you for being with us. Don't forget to share and subscribe, and check out our other media for other news. This podcast is sponsored by IEEE Intelligent Transportation System Society. This was Dr. Mariam Kavishkar from IEEE ITS Society. Dear listeners, if you are interested in helping or participating in our program, please let me know. You can join us as volunteers and have your share of podcast every time.